in order to get a bunch of stuff out of our main Julia repo for Julia 0.1. And then at some point, I revised that and it got somewhat better. And then, we realized for a whole bunch of reasons that it really needed to be replaced. And we're actually going to start by talking about where we were, negative and positive, and hint, it is mostly negative. But there's some positive. So if people have developed packages or poked around inside of packages, they'll have noticed that there are these things called require files. Capital require, no ending, and it's this format that I just made up because I didn't really feel like messing around with parsers, and this is a really, really easy format to parse. And it's just the name of a package and then a sequence of version numbers. And this seems to have confused people more than I thought it would. They are open, closed, closed, and then open intervals, which you just take a union of, and that's the set of versions that are supported. And if you have nothing, you support every version. If you have just one version, then that's a lower bound, and there's no upper bound. This seemed remarkably straightforward to me, and then everyone is completely confused by it because apparently that's not how human brains work. Yeah. So but I mean, part of it is just if the thing on the right, if the comment is what makes it clear to people, then maybe we should just write that. So, it's a non-standard file format. It's, you get a custom parser and writer. The upside is it's really simple and easy to implement. But there's sort of this proliferation of these little custom file formats, and at some point, you have to have a dictionary to look up which custom file format you're using, and that gets tedious. Common usage has no upper bounds, which is kind of bad because you're basically committing to supporting every possible version of your dependency ever, which we know doesn't work. People upgrade their APIs and break them, and then that shouldn't work, right? You shouldn't be promising about a thing that you can't really make promises about. There was also this idea of, I think this worked remarkably well. There's a metadata.jl directory, which is just it's a big Git repo, and it has a bunch of files and directories that describe what packages are, where you can find them, how they relate to each other, how they depend on each other. One problem is that there's only one registry. There's only one of these. I had originally thought that maybe people could, maintain their own branches, their own forks of this, but that turns out to be wildly impractical, and nobody wants to do it, and it's a nightmare. And in any case, even if you're maintaining your own copy, it's still a shared global namespace, because if one person has one copy and they want to upstream or downstream stuff from somebody else, then there's merge conflicts, and you have to agree on what a name means. So there is still effectively only one shared global namespace. There's no really good way to support private packages. You can, at least not in the registry, right? You can't have your registry of your own private packages. You can have your own private packages, just stick them in a directory somewhere, that works. There is this problem, which I actually encountered in the wild a couple of times, where you have a private package and it's got a great name and you're really happy about it, and then someone publishes a package with the same name, and something you depend on depends on that. So you don't even have to be using it directly. And then you upgrade your code because you want the latest and greatest version of the thing you're actually using, and now there's two things by the same name and everything breaks. And unfortunately, the current, in the old system, the best advice you could give is, well, rename your thing. Sorry, that's kind of shabby. So it would be nice to do something better. And then, a version in this system was a git commit. That seemed like a good idea to me at the time, because I thought, okay, well, a git commit that captures, not only the state of the source tree, but also how you got there, and it seems like it's harder to mess with. It would be harder to, accidentally somehow get something that wasn't what you intended. This was a bad idea, because it turns out then you can't edit package history, because by editing package history, you invalidate all of, the only thing you really cared about is what are the source files that I'm going to install and load. But now you have all of this baggage, this past baggage, that are part of the identity of a version, and you don't really want that. And we'll talk a little bit more about why. Lots of little tiny folders and small files, which I thought at the time going into this, I was like, that's a thing file systems are good at, right? It is not, as it turns out. It's a disaster on Windows in particular, and network file systems really hate this. So don't do that if you're ever designing a file system format. Yeah, so the old package manager, the code itself, which we've renamed to old package and put in the Julia archive repository, it has to download full Git clones because in order to, a version is a Git commit, and in order to get that version, you have to have a full Git history. And you can do some, tricks with shallow clones, but that doesn't really work that very well. And even to do a shallow clone, I think, you end up getting much more stuff than you really needed. So the latest release, for example, of plots.jl is only 196 kilobytes. So that's all you should have to download, right? No. You have to download all 113 megabytes of this repo because there was a bunch of stuff in there previously, and now, do you care about that? No, you don't. But Git cares about it, and so you have to download it. So good times. And we can't rewrite history because then when you rewrite history, then you're going to invalidate all of those old version commit hashes. So that's also not great. There was also this design, I thought this was a good idea at the time, where you declare what you want, and then you just, based on just what you declare, what's available and what you've declared, you get a full resolution of all of the versions, and there's no the previous state of your versions doesn't affect the new state, but the side effect of it is this. Add a package, okay, I have to upgrade everything. That's a little weird, but sure, I guess. Update, okay, why do I have to upgrade everything? I just wanted to upgrade one thing. And then the worst, the real kick in the teeth is delete a package, upgrade everything. Why? All I wanted to do was delete something. That's terrible.
I think it's even if you test the package, it almost upgrades everything.
Yeah, there's like nothing you can do that doesn't want to upgrade everything. This is the old package manager is very opinionated that you should be living on the bleeding edge at all times. So you can pin packages, but then you don't get up. It doesn't work well. So there was also just one shared environment by default, so everything lived in tilde.julia version 0.x. So there's a couple things that are bad about this one single shared environment. So first of all, if your resolver ever gets stuck, which it tends to do sometimes, then all of your packages break. All of your projects break. It doesn't matter where they are. They're all sharing the same set of packages. So now, great, I broke something over here, and now everything doesn't work. That's not great. There's also no package management, no package manager for you until you fix this. So it's not like you can go work on something else. You're kind of stuck, and then the standard solution is just delete this whole directory and hope for better luck next time. There is this Julia package directory thing that allows you to make another directory, sort of point it somewhere else to make a copy of this, and you can kind of get an environment type thing working with that, but it's awkward at best. And it's very hard to record you can't really snapshot that. You can have more than one, which is nice. But then there's no way to talk about what was the identity and state of a particular version of that. You can stick those in Git, but it would be nice if it was easier to just record what the state of everything was. So one of the upsides, this I think was a really nice piece of this design, was that it's really easy to turn a user into a developer, and you may or may not want to be turned into a developer willfully, but at least the option is there for you, right? Like if you have something installed, you're already in a position to look at the code and edit it and even just, make a PR right there. The downside is that, now, there's this question of is this the version of the package speaking as the package manager, personified, is this the version that I installed? Am I free to change this and delete it and do whatever I want with it because I put it there? Or is this something that the user has done and they've got their own code in there and I don't want to delete it or mess with it? And we've had a couple of bugs where people's work got deleted, and that's a really terrible thing to do to somebody. They put a bunch of work into something, and then your package manager goes and like deletes it, their work. That's not cool. And a lot of the complexity in the old package manager was due to that. So trying to avoid deleting people's code. So it'd be nice to have a design where you didn't have to worry about that in the first place. Code loading, so it's pretty simple in the old version. Basically, you have this thing called load path. It's a bunch of directory names, and then you look in each directory for a thing that's called, x/source/x.jl, and if that exists, that's how you load the X package. And you just load the first one you encounter. The downside is that, you can actually end up in a situation where you resolved something and installed it, and then that's not actually what you end up loading. It's hard to do, but it can happen. And also, everything is based on this implicit global mutable state. It's all just like, what happened to be on your hard disk? I don't know, who knows? Maybe it was this, maybe it was that. And of course, then later, if that's changed, there's no way to recover what the hell you were doing in the previous situation. So sharing your state, if you've ever tried to reproduce a bug and say, well, it's not working for me, and it's broken, and someone's like, well, I don't know what you're running, or or the other way around, it's working for me. How do I share a working state with you? Both of those are very hard to do. So, okay, installing things mostly just works. That's actually a really nice feature of this system. And sometimes I feel bad about things, and then I try to use a Python package manager, and I'm like, oh my God, at least our stuff works. I know Conda solves this problem. It's true. So Conda is the blessed thing, but you have to install. I don't know. I don't understand Python's package manager system. Ruby's got it, seems to have it right with bundler these days. They're third time's the charm. Maybe that's a thing. Hopefully third time's the charm for us too. It's easy to develop packages. That's good. We'd like to preserve these two things. Bad performance, large downloads, no isolation between projects, hard to control individual packages, and not reproducible. Yeah, it's a long list of bad stuff. New design. Fix all the things. So use TOML everywhere. TOML is it's Tom's obvious markup language. It's Tom Preston Warner. It's the same guy who brought us semantic versioning and GitHub itself. He was one of the co-founders of GitHub. It's the nice thing about TOML is that it's very straightforward. It's like a 15-minute read to read the spec. It is very simple to read and simple to implement. Other options that people would consider JSON. It's not, you can't put comments in JSON. It's not really a human readable format terribly much. YAML is also used for this sort of thing, but it's actually super complicated. If you look at the spec, it's very, very long and hard to understand, and has a lot of weird implicit stuff in it. So TOML just seems like a good choice. Cargo and one of the new Python package managers, I think, uses this. So it's got some precedent. So we want to do fewer files. So not lots of tiny, tiny files. You don't want like a URL per file, which is actually how the old package manager does things sometimes. So you want fewer files, but you don't want so few files that you have to parse one enormous file in order to be able to do anything. So what you want is like enough of one big file that tells you what your packages are and where to find them, and then parse another package because I have a dependency and I want it, and then I can look at the things it might be interested in and then only parse those, and so on. And you want this to scale with the amount of stuff you want to install, not with the amount of stuff you could possibly ever want to install. So that's a careful design issue. We wanted to couple names from identities. We've had a couple of issues where renaming something wrought huge havoc in the ecosystem. And also when you have private registries, if people have private packages, you want to solve that problem where someone publishing a package with the same name as your private thing doesn't cause you to have to rename it. So we want to decouple a package identity from package name, which will solve both of those problems. But it's trickier than it sounds, because you just don't have a shared global namespace anymore. So we want to eliminate implicit global mutable state too. That's a really key thing. So one idea is immutable package installation. You install a thing, you don't touch it. That's it. It's just there. If you don't need it anymore, you delete it, but you don't mess with it. And you separate, the development copy that the user has from the like package manager installed copies. Content addressed code loading. So the idea is, tell the system, well, I want to load the version of this package that has this tree hash. And then it finds or installs that and then loads it for you. But you can't possibly get the wrong version because you told it based on the tree hash what you wanted. So that, you're getting rid of, the global mutable state of oh, it's just whatever was on disk. I don't know, whatever's there. Capture exact dependencies in state in files so you can snapshot things, and then allow per project dependency graphs. So, this project over here can have one set of versions, and this project over here is a different set, and they don't have to step on each other's toes. So one of the challenges here is that you still want to, allow interactive REPL usage. So that's sort of at odds with just declaring everything you ever want to use completely precisely. People need their debugging tools, or just, I'm sketching some stuff and I don't want to be bothered with that. So we've tried to balance those. So this is one of the files you're going to have in a project, and it's called project.toml. And you have a name and a UUID, and the UUIDs for currently registered packages have to be generated in a certain way, but in the future, they'll just be randomly generated UUIDs, and there should never be any collisions because there's 128 bits in there. And then you declare your dependencies, and you say a name, and it equals a UUID, and that UUID says which JSON package. So if someone else comes along and is like, well, I have a JSON package, and I think it's much better, they can use the same name. You can't use both of them in the same project, but someone doesn't own the name JSON forever. You can have two different things with the same identity, and one of them could be private, one of them could be public. Doesn't really matter. And then you declare compatibility. This format is it's not as intuitive, I think, as the open-closed interval thing, but it is a very standard thing that people have been using in other package managers. So NPM and Cargo use this format, and it seems to work pretty well. So basically, this JSON equals 0.16.3 means this caret thing by default, and it basically means everything that should, in theory, be compatible with that, based on semantic versioning. And this is all written out, and it's also exactly the same as these other package managers. So if it's working for them, it seems good enough for us. So common usage does have upper bounds. We're not lying about we're going to support everything forever. It's a bit more complicated. I think Jeff joked that we should call the new package manager hex because there's all these hexadecimal numbers in it all over the place, which is true. But mostly, you don't have to write these by hand. The package manager puts them in there for you. They also have the advantage that they're permanent, right? It doesn't depend. You know what this thing means regardless of how registries change or things move around forever. You can take a project and a manifest file and just be like, I know what this means. Okay. So manifest files, this is the part where you snapshot all of the versions of everything that you want to load and depend on. They're automatically generated. You don't have to hand write these. This is what the resolver outputs. So it looks at a project file and looks at what's available in registries and says, okay, boom, here's what you're actually going to use, and that's the manifest file. From the combination of the two, we know exactly what is going to get loaded and used. And you can install them for the user because you've got the two files. You can just, I'll go get that for you. They're pretty lightweight. It's just two files. And you can send them to people, and you can also, check them into version control. This is what a manifest file looks like. It's more hexadecimal. You can see that there's a section for each package, and then it lists its dependencies and gives its UUID. You can actually have more than one. So if there were two things called JSON, there could be two stanzas here, and they could refer to different packages. The main project wouldn't have to refer to two things named JSON, but if one of your dependencies referred to a different JSON, that would be fine.
We should note that this file is not generated. You're not hand editing it.
Yeah,
it's automatically generated, so you don't really have to touch this at all.
Yeah, but it is still human readable, which is nice, and the same toml file format. You still look through load path. The difference is now a load path entry can either be an old school package directory where you just look at x/source/x.jl. That still works. but it could also be a directory with a project and manifest file. And that describes a dependency graph in a different way, and that all just kind of works smoothly. The first one you kind of think of as like your primary project. That's the thing I'm actually working on. And the rest are like my dev tools, and then the JuliaZone standard library will be in there too. There's also a thing called depot path, but you don't really need to worry about that. And then registries, so just high level, smarter storage. The new version is less than half the number of lines, and a lot less than half the number of files, only 8,000 files. Compared to the current metadata. But most importantly, the number of files that you actually have to parse is on the order of the number of possible dependencies of the thing you're trying to install versus on the order of all of the packages that we know about, which is obviously going to be increasingly important as we have more packages. Name collisions are fine because UUID equals package identity instead of name. Now we're going to get to the exciting part where Christopher shows you how this thing actually works.
Yeah, so now you heard in theory about all this good stuff about the package manager, but maybe we should look at it in practice as well. So I'm just going to put up my manuscript here so I don't forget what I'm going to be doing, because if I don't have this one, I'm going to do stuff out of order. So let's start with deleting .julia, so we start from a clean slate. I have to lower the. Yeah. So as you know, Julia has a bunch of REPL modes. So for example, we have if I press question mark, we get the help, so we can search for help from the time function. We have the shell mode, for example, I can clear here. And in 0.7, we have a REPL mode for the package manager, which is with closing square brackets. So now I'm in the package REPL mode. So we have a help mode here. If I press question mark, you see the help and all the commands. We can look at the help for add, for example. Here's some examples and some help. So let's try to install a package, let's say JSON. So at first now, since I deleted .julia, it has to get the registry. And it does that automatically. So you can see up here, we got the new registry called general. We installed JSON, so we have a diff from what the environment looked like before to now. And then here we have all the dependencies of JSON. Right now, these are mostly standard libraries, and they all sort of depend on each other right now, so that's why there's so many. And if we go into the .julia folder now, and we look at packages, we have JSON there. So, but inside there, it's not the JSON source code. It's just some weird folder there, and that's based on the content or the version we installed. So if we install, let's say another JSON, version 0.17, and we look down here in the JSON folder again, now we have two JSONs installed, both of the different versions. We can take 0.18 as well, and now we have 3. And since these are not full Git clones, they're very small, it's fine to store them like this. And if we delete JSON, I mean, the installations are still here, so deleting and adding is just literally just writing to a text file, so pretty fast like that. So another thing that's good with having a REPL mode is that we have tab completion. So if I do, for example, add X, and now I press tab, you can see the possible packages that we can install here. So if I want to install example, I can press tab like that, install it. There we have example as well. And to install a package from a URL, it's pretty simple. You can just add the package from the URL. It's going to clone the Git repository from there, and it's installed now. And if we go to our package directory, you can see we have these import macros, which I just installed from the URL. So you can look at the status of our project, and we have installed example, import macros, and JSON here. And we can also see that import macros are tracking the master branch and the Git repository here. So let's try to be a little bit mean here against the package manager. Let's just delete the package directory, and the clones. So now I've actually deleted the packages that we just installed. So let's do status again. Well, now it complains a little bit. We have these red arrows here on the packages, and it says like some packages with a red arrow are not downloaded. So it knows what packages we should have, but it recognizes that these are not actually downloaded. And it says use instantiate to instantiate the current environment. So if we would have tried to load a package now, we would get an error because the actual files of the packages are not there. So let's try to instantiate it then. So now since we have everything declared in the manifest, we know exactly what we want. So we can just install it again. And we see we cloned our unregistered packages, we installed example and everything we needed. We go back to our package directory, they're still there. So, and now if we try to load JSON, it works. So like you could just send, for example, the project and manifest you had here with all your unregistered packages, with weird versions and everything, and you can just instantiate, and then you're ready to go, exactly reproducible environment. And one thing we mentioned before that was good with the previous package manager was that it was so easy to develop for it. You already had the full Git clones, so that's something we wanted to preserve. So if I instead now do dev JSON or develop JSON, we're going to actually download the full Git clone for you. So now we went from having the version 0.19 actually having this in a path instead. So if I go to the .julia.dev by default, you can set where this should install. We have JSON there, and we can see now here that this is a Git repository. And if we do like this, we can see we're tracking the correct origin. And if I now were to change something in here, let's just put something like that. So now I edited the file in here. And now if I try to import JSON, you see that the one that we developed is used instead. And that's because we're tracking this by path. So this is something that we can develop for when we've used this dev command. And the package manager will never touch anything that's tracked by path like this. So it will never accidentally delete anything like this. This is completely untouched by the package manager. It's up to you to do whatever you want in here, and we will just load that stuff. So another thing we wanted to do with the new package manager was to make it easy to have different environments. So let's say I do activate. That's how you activate a new environment. Let's call it my project, like that. You see the prompt here changed, so we can see which active environment we have right now. And if I do status, oh, I already had that. This one shouldn't be. So now it's told me that the new environment will be placed there instead of using the one I did when I practiced this talk. So now it's empty, like it should be. And let's say we add JSON again here. Well, this time it doesn't need to install it, right? We've already downloaded it from before, so we're just pointing at the previous thing that we downloaded. And since these packages are immutable, it's totally fine for many environments to use the same package because it's not going to be touched. So we could dev JSON here as well. And by default, we're going to use it's sort of like a global development path here in .julia.dev. So it tells me now there's already JSON in there, so we're just going to use that one. But sometimes you might want to have many dev versions at the same time. So then you can just say, we want to have have it locally. And if we go to my project now, it's in the dev, then we have a JSON there as well now. So we can have many development versions independently. And another feature that was, let's add some stuff. Another feature that was requested was that, many times when people make presentations and stuff and they start it starts to precompile for quite a long time. So it just precompiles the first time you use it. So it's kind of nice if you could just write precompile and it would precompile everything in your project. And now everything is precompiled. So if you import let's say JSON now, you don't have to precompile it. So like when you've done a bunch of stuff, you can just write precompile, and then you know everything will be precompiled. And when you have your presentation or something, you don't have to wait like that. Okay, so one thing you might be thinking now is, well, I'm going to have a bunch of these versions in here, and isn't it going to take a lot of space? Like I'm going to have every single version. And yeah, it will, but the fortunate thing is that we have a garbage collector. So if I just write GC here, it knows what your actual environments that you've used are, and it knows what packages are used by those environments. So it figured out here that this specific JSON was no longer used anywhere. It's sort of dangling by itself. And since things are immutable, we can just safely delete it. So let's say if I remove timer outputs here. Now nothing in my project is using timer outputs anymore. So if I GC now, it deleted both crayons and timer outputs. And that's just because we know everything is immutable. And stuff that are dev'd, they will never be deleted by the garbage collector either. And last, I want to put the new package manager to the challenge and have it compete against the old one. So let's make it a bit smaller. So I'm going to install, oh yeah, let's do everything from scratch as well. I'm going to install differential equations with the old package manager. Yeah, that's the torture test, is what I use. Let's make things kind of small so we can. So on the right, we're going to have the new one, which is just, huh? Yeah, that's fine, because the old Pkg is, we still have old Pkg. So let's give the old one a little bit of a head start. And then hopefully we'll do the new one. Okay, so now we're cloning the registry to the right. Done. Resolving. And now we start to download packages. We haven't even gotten metadata on the left. So yeah, let's see. Oh, it started. Our pack is coming, banded matrices, bin deps, and these are Git clones, so they take a while, but I think there's 80 or something of these total independencies, so yeah.
I want to point out that Christopher killed the build because we don't need to watch it build, but it,
oh, yeah.
it succeeded.
Yeah, it's just, here it downloaded everything, and it started building, and then I canceled it because that's not the package manager thing. Yeah. So, yeah. Okay, so we're actually out of time. Very quickly, I just want to say that there's a few things left to do, and that is to transition the whole package ecosystem from require files to project files. And our plan there is to use some kind of automated thing with like femto cleaner that sort of upgrades the packages for you. There's no real rush. Require files still work, so there's no need to worry. But this is a work in progress with high priority. One problem we have is that when we have many versions and they all have binary dependencies, then that can be quite a lot of file size. So we want somehow that you could depend on binary dependencies so that you don't have to install one for every version of the package. And this ties into a little bit of the work on the binary builder and binary provider, which there is a talk about tomorrow, I think. Yeah, just want to acknowledge everyone who's been helping with this. It's not just we two, it's everyone here, and people have been filing issues. And package manager is a really complicated system, and you need people that test it out, fill good issues, reproducible, and we can fix it, but we need to find out that they actually exist as well. So thank you, and questions?
We are sadly completely out of time, but we have time for one very quick question.
All the commands that you ran in that special package mode, are they available from the main REPL?
Yeah, so there's also what I call it, oh look, the old package manager is still going. There's a bunch of, you can just write pkg.add, for example. There's like an API interface as well. So when you're like interacting with the package manager from code, you don't want to use the REPL interface. So this is just for convenience when you sit there, but there's also like a completely, like an API interface as well.
It's a little bit less complete than the REPL, but we're working on getting it to parity.
It should be pretty
almost
good right
everything
now.
from the API. And if there's anything missing, file an issue and we'll add it.
Build.
Build. There's a build command.
Build. Yeah, well,
Yeah, we're working on
should be
that.
fair. Like, I improved the documentation quite a lot recently, so it might be better now. Okay, thanks.
Thanks. Thanks, everyone.
Yeah, okay.